This lesson will show you how we can use our knowledge of certain special right triangles to compute exact trig values. In class, you learned about using sine, cosine, and tangent to solve right triangles, and you used your calculator to get answers. You might have noticed that your answers were always long decimal numbers, or usually, and those are not really exact values, and that's in most cases good enough to approximate. There's a few special cases, however, where we can be more exact, and of course mathematicians like to be exact wherever possible. We'll start by considering in greater detail the 45-45-90 triangle. That means that the two acute angles are both 45 degrees. And in order to compute trig values, sine, cosine, and tangent, we know that all 45-45-90 triangles are similar, so I can just decide whatever length I want to use for this side length. I'll just say that it's 1 because that's a pretty easy number to work with. Now, we know that from geometry that if the two acute angles are equal, that means this is an isosceles triangle and those two side lengths are also equal. So I'll go ahead and also place a 1 right there. Now I'm going to use the Pythagorean theorem to find the length of the hypotenuse. Well, the Pythagorean theorem says that a squared plus b squared should equal c squared. And in this case, a and b, the two legs of the triangle, both measure 1 unit. 1 squared is 1, so 1 plus 1 is c squared, and 1 plus 1 is 2. So solving this equation, if I take the square root of both sides, I discover that c is the square root of 2. So that means that I can place a square root of 2 right there. At this point, you should pause the video and you're going to turn in for your homework, among other things, a copy of this triangle that I'm circling in red. So pause the video and copy that down onto a sheet of paper, and that will be the first part of your homework assignment. Next, we're going to consider a 30-60-90 triangle. Now, this triangle that you see in front of you isn't really a 30-60-90. It's an equilateral triangle, which means that all three of its angles measure 60 degrees. So I'm going to go ahead and label this 60 degrees. And again, I can be arbitrary about what side length I want to give each side. So I'm just going to say that the length of each side of this equilateral triangle is 2. Now, what we really want is a right triangle with angles 30, 60, and 90. So if you think about splitting the equilateral triangle in half, that's what you get. We know from geometry that we've split the side in half. We also know that this angle is 90 degrees. And since this one is 60, that means this one up here must be 30. And like I said, since this median would cut the bottom side in half, its length must be 1. Now I'm going to go ahead and clean this up by getting rid of the equilateral triangle so we can focus on the 30-60-90 triangle. And again, I'm going to use the Pythagorean theorem to find the missing side length. So a squared, let's say 1 squared, plus b squared. Well, the other leg is the unknown in this equation, and that should equal c squared, or the hypotenuse squared. So 1 squared is 1, and then 2 squared is 4. I subtract 1 from each side, so b squared is 3, and then taking the square root of both sides, I discover that b is 3. So let me go ahead and place a neater square root of 3 right there. And again, I'm going to circle in red what you need to get onto your paper that you're going to turn in as homework. This 30-60-90 triangle goes onto the same sheet of paper as your 45-45-90 triangle. So go ahead and pause the video and get that onto your paper. For your homework, I want you to look at the two triangles you've already been asked to draw, and by using those triangles and what you know about sine, cosine, and tangent, I want you to fill in the chart that you see using exact values. That means no decimals. Go ahead and leave square roots in your answer wherever necessary. Have that ready for class next time.